Find the distance.
Alright, how you doing? I'm your man, John Wilson. Today we're going to finish up 112. We're going to do 12 3. We're going to finish up with a Pythagorean theorem, 112. We're going to move on.
Then we would identify a postulate on the
That means
basically
today we will
why
understand
how to use the Pythagorean theorem to find the
distance.
distance.
Sorry, a fancy way of saying
I'm going to
points
introduce you
on a coordinate plane
distance.
rapidly.
Point.
Then we would identify the first part of it, all related to
on
the
the
algebraic
plane
reasoning we
and
required
to derive.
I want to make sure that we all understand.
What?
Sorry, a fancy way of saying I'm going to introduce you
A triangle.
This is drawn by me. What type of triangle is that? The
It's
first
a
part of
right
it all
triangle.
relates to the
Right
coordinate
triangle
plane.
doesn't matter
And
which way it's oriented.
I want to make sure that we all understand.
I turn it like that. Is it still a right triangle?
What?
Yeah.
Still a right triangle. Still a right triangle.
All
All
that
that
is
is
what type of triangle is that?
right. It's a
Triangle.
right triangle.
What we care
right
about
triangle
specifically
doesn't matter
is
which
what
way it's
theorem
orientated. Find the missing
I
measures
turn it like
of
that.
a right. Still a right triangle. What's it called?
Yeah.
Still a right triangle. Right triangle. All that is we can use this same theorem to triangle. What we care about specifically is what theorem can we use to find the missing measures of a right triangle. What's it called? A Pythagorean theorem. And we can use this same theorem. We have one diagonal distance. We could always go in and draw on the right triangle. Couldn't we? Find the distance, and that's how we can find the distance between 2 points. There's another formula that we're going to use called the distance formula. You might simply realizing that if we have one
First and
diagonal
foremost, we
distance,
can use the
we can always
Pythagorean
go in and
theorem, like I
draw
said,
on the
to
right
find the
triangle
distance between 2 points.
on a
graph.
graph. That's how we
Here,
find the
we
distance
have
between 2 points. There's
A
another formula that we're going to use called the distance formula.
Now, when I put those points on the graph, do you think there was a right triangle drawn
First
in
and
there?
foremost,
We
No.
can use the Pythagorean theorem. Like
What
I
I
said,
did is I
like
connected point A
on the
and
graph.
point B
Here,
diagonal
we
line,
have
and then
point
I
A
drew in a right
and point B.
triangle.
Now, when I
I'll show
put
you
those
guys how to
points
do
on the
that
graph,
in a
do you think there was a right
First,
triangle
though,
drawn in there?
Let's
No.
see how
No,
we can
there
use
was
this
not.
to find the distance.
What I did is I connected point A and B.
and
What
point
is the
B
distance
diagonal
between
line,
points A and
and then I
B?
drew
What's
in
this
a right
side called? So it's an
triangle.
H. What's it
I'll
called?
show you guys how to do that.
The hypotenuse.
Let's
This is
see
known as the
how we can
hypotenuse,
use
the
this to
longest
find
side,
the
the diagonal.
distance.
We know
Points
the
A and
legs.
B.
What is the
What are
distance
the legs
between
of the
the
legs?
points
Here.
A and B? What's this side called? Starts with an H. What's it called? 2 and the hypotenuse. This is known as the hypotenuse, the longest side, the diagonal. We know the legs. We know the length of the legs. We can go and substitute that into our theorem. In case you remember this from last time, 2 a squared plus b squared equals c squared. We're trying to find the hypotenuse. So we are going to substitute. Once we know the measures of the legs, we can go and substitute that into our theorem. In case you remember this from last time, we know a squared plus b squared equals c squared. We're trying to find the hypotenuse. So we are going to
That
substitute
equals
this
c
in.
squared.
We're going to get 2
We
squared
combine
plus
our terms,
4
we get
squared
20 is equal to c
squared.
squared.
What's 2 squared, guys?
And what do I have to do to finish this
Plus,
up?
what's 4 squared? Calculate. What do I get to finish this up?
16. That equals c squared.
I have to
We
take the root of
combine
both sides in order
our
to get rid of
terms,
this
we get
exponent.
20
So I'm
is
going to take the
equal
root
to
of
c
20
squared
and the root of c squared.
And
what
I
do I
end
have
up
to
with
finish
all I
this
want for this,
up?
guys, I don't want any
Calculate. What do I get to finish this up? The radical answers, I want everything in decimal form.
Take the root of both sides in
Find
order
the
to get
actual
rid of this
distance.
exponent.
So what's the root of 20 to the nearest 10?
and the
What
root
do we
of
got?
c squared,
Four,
and I will end up with all I want for this, guys, I
4.5.
don't want any
4.5 to the nearest
The
10.
radical
So
answers,
C
I want everything in
equals
decimal form,
because we're trying to find the actual
0.5,
distance,
which
here.
means the
So
distance
what's the root of
between
20
point
to the
A
nearest 10? What do we got?
and point B is equal to
4.5? 4.5 to the nearest 10. So C, now once again, like I said, this problem can also be shown without decimals, which means the distance
Just
here
by
between
saying
point
C is
A,
equal to what?
what could we left it as?
Point
That's a
B
non-perfect square,
is
you
equal
left it as
to
what?
C
C is equal to the square root of 20. That is another way to do it. Now once again, like I said, this problem can also be shown without decimals. Identify that is a
Just by
decimal
saying
answer.
C is equal
I
to
will
what?
never
What could we
actually
left it
ask
as?
you. That's a non-perfect square. I left it as what?
Square
C is equal to the square root of 20. That is another way to do it. It's a possible answer because
Keep
this
putting
is
this
a
up here just so you
rational
identify
number.
that is a
possible answer. I will never actually ask you some of this on a quiz or
on
your
your
FSA.
FSA.
If it appears on your FSA, I want you to know that this response, technically
solves
square root of 20 is a possible answer because this is a rational number.
are
with a
correct, plural,
you could choose both. So
always
that
make
would
sure
be
you
acceptable
know.
on your FSA if
Now,
multiple choice or multiple
the
response.
right triangle is not
solve
always
square
going to
root
be
of 20
drawn.
and this, and it said
for
which
us.
answers
Here,
are
we want to
correct,
find the
plural.
distance.
You can choose both. Always make sure you know.
Let me walk you
both.
through how we start with 2
Now,
points and we
The
end
right
up
triangle is not
with
always
a
going to be
right
drawn.
and
First, you identify
here,
points B and E.
we
We
want
want
to
to point
find
B and E up there, yes or no?
Yeah.
Yes, point B.
let me
And
walk
point
you
E.
through.
We want to
how we
connect
start
it
with
with
the
two
lines.
lines. What type of line are we going to
End
connect
up
it with?
horizontal, vertical, or
Diagonal.
Diagonal.
Because first, you identify points B and E. We see points B and E up there, yes or no? So we go to point
Yes.
A, point B, point E, we connect them with a line. What type of line are we gonna connect them with? Now, you can try to estimate the distance there,
Diagonal.
because we're creating a, so it's an H close. The whole way to connect point E to actually go in, and we connect them one of two things. One, now you could try to estimate the distance there, but you're not gonna get an accurate distance, you'll get something that's close. The only way to get an accurate distance is to actually go in and use one of two things. One, Pythagorean theorem, which we're gonna do now, later on in the distance formula. So now, and B to E, okay. The way you draw in a right triangle, there's one of two ways to draw in a right triangle here. One of two ways. Remember, we're drawing a right triangle, that means that we're gonna need to create something with a 90-degree angle. We start at point B and point E. Here's the first way to do it. You simply, from point B, you would go down, point E, you go right, until you figure out where they meet. They meet right about there. Once you figure out where they meet, you're simply drawing in your right triangle. Is that the only way I can draw in the right triangle?
No.
No. Couldn't I also have gone the opposite direction? Remember, you're drawing in a right triangle. So that means that the two legs you're drawing in should meet at what type of angle? Oh, what type of angle? A right angle, 90-degree angle. So we go from B. Did I go too far?
Yeah.
Yes, I did. Gotta be careful. We're right above E, and we go right down. Doesn't matter which way you do it, you'll get the exact same answer. Because all we're doing is drawing in the legs. Once you've done this, you go and you simply identify how long each side is. If you look at the graph is going up by ones, which means each block is 1. So 1, 2, 3, 4, 5. This is 5 units long. What about the other leg? How long is the other leg, Ms. Tavares?
6.
6. 5 and 6. Once we know the lengths of both of the legs, that is simply our cue to substitute these into what theorem?
The Pythagorean theorem.
Sean, tell me, what am I going to write?
6 to
Well, let's try to start with the smaller measure, right? A, B, C. What's the smaller one, 5 or 6?
5
5. So 5,
and square root
5, not square root, just 5 squared, plus what?
6
6 squared, okay, good, is equal to? Do we know what the hypotenuse is yet? No, so what do we use for the hypotenuse?
like B
It's not B, A and B are the legs. What do we use for the hypotenuse?
C
C squared, okay. So what's 5 squared?
25
25, plus what's 6 squared?
36
36, that equals C squared. We combine our terms, we get 61 is equal to C squared. We've seen that number before. We take the root of both sides, we're gonna round this to the nearest 10th. And that's gonna give me C is equal to what?
7.8.
7.8. I think it's like the third time we've seen that specific and non-perfect square in the previous lesson. Sorry. So C is equal to 7.8, which means that the distance between E and B is approximately 7.8. We rounded it, 7.8.
How is it
This square root of 61?
Yeah.
Yeah, there was. All right, let's try another one of these. The distance. Right now, though, we're still working with the graph. This time I want to find the distance between points A and D. So Nolasco, what's the first thing I have to do?
Yeah.
Okay, but step one, what's step one?
Connect these 2 points.
In this case, A and D, we connect them with a line. What type of line? Vertical, horizontal, or diagonal?
Horizontal. And diagonal.
A diagonal line because we're creating a hypotenuse. Plus, that's the only line that will connect A and D. Horizontal, vertical, wouldn't connect them. So we stretch a diagonal line between A and D. And then what do we do?
Identify the legs and the hypotenuse.
All right, identify the legs and the hypotenuse. We drew in the hypotenuse. Now we need to draw in our legs. So, what's up? Question?
Yeah, I forgot what a hypotenuse.
Hypotenuse is the longest side of the right triangle. So let's back up to this one here, all the way here. Let me clear all this out for you. See how this is a right triangle? It's kind of standing up. These are the legs, the shorter sides. The longer side right here is your hypotenuse. It's always the longest side. So if I were to say this is 2 and 4, could this be 3 right here? No, because it always has to be the longest side. Okay, backing up here. So we know that's going to be our hypotenuse. Now we need to draw in our legs. So we have to draw in a right triangle. Do you want to do the top one or the bottom one? Top one. So what you're doing is you're going to start at A, and you're going to go to the right until you get directly above point D. So we'll stretch a line. Are we directly above point D? Yes. And then from there, what do? We go down to D. Now we've drawn in our right triangle. Once you draw it in, you simply calculate the length of both the legs. Matthew, what are the lengths of both the legs?
The top one's 5.
Top one's 5, and the bottom one is
4.
4. Good job. Once you know that, I mean, that's the hardest part. You simply substitute these into the theorem, and I'm going to have 4 squared plus what, class? 5 squared is equal to C squared. I'll get 16 plus 25 is equal to C squared. I combine, I root, and what is C going to equal to the nearest tenth? 6.4. Why is it writing in the Sanskrit alphabet? I don't know. 6.4. Is that good? 6.4? 6.4 is a good answer. No math routine. Any questions on how to do this? Any questions? All right. Now, here's the thing. Next step is to use the distance formula. Now here, I've still left the graph up just to show you how this works. Once again, keep in mind, quizzes or tests, you will not have the option to use the graph. You will only have coordinate pairs. We want to find the distance between points D and E. This is the distance formula right here. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is not a difficult formula. It's simply substituting your x and y values in. You're squaring them, subtracting them, you're going through the process. First though, let's figure out what we're trying to find the distance between D and E. Now if the graph wasn't here, you would just be given coordinate pairs. So can you give me the coordinates for Shman, for D? What's the coordinate for D? 3, -1, okay? And then Yama, what is the coordinate pair for E?
-2, -4.
Perfect. -2, -4. Then we have to go and we got to choose where we want to be our x2, y2, x1, y1. When you're doing this, easiest way to do it, to make sure you get at least one positive set of numbers, is make your larger x your x2. Remember how we made the larger y the y2? Way back when? Pick your larger x, make that your x2. So what's going to be your x2 here? 3. So that's my x2, which means this has to be my x1. This is going to be my y2. Has to be. This is x2. This has to be your y2. This is x2. This has to be your y2. This is x1. This has to be your y1. Okay. We're going to substitute those points in our formula. So we have our square root, parentheses. What is my x2? 3. Immediately write the subtraction sign. It's part of the formula. 3 minus, that's a -1. -2, sorry, I was looking at the wrong one. 3 minus -2. Let me fix that. 3 minus -2, I know. Squared. And then what? What happens in the middle here? What can you not forget?
-1.
No, what happens right here in the middle?
Plus.
We're adding. We're going to do the y values now. What's my y2? -1. Immediately write the subtraction sign. Parentheses. What's my y1? -4. Parentheses. Don't forget to square. Okay, so we deal with the first one here. Can't forget that minus there. 2 negatives together make a positive. That becomes 3 plus 2. What's 3 plus 2? 5 squared. So we're going to do 5 squared plus. 2 negatives here make a positive. What is -1 plus 4? 3. That gives me 3 squared. What is 5 squared? 25. What is 3 squared? 9. So you end up with 25 plus 9. What's 25 plus 9? 34. And what's the square root of 34?
5.9.
5 to the nearest 10?
5.8.
5.8.
It's 5.8 what? What's the hundreds? What's in the hundreds column?
It's like a 3.
5.3.
So it's 5.8. So distance is 5.8. That's all you're doing. You're simply substituting in values. It just takes a little bit of practice. That's all it takes. Any questions on this first one? Anyone not understand how we got these values? Let's review here. Your x2 is always going to be your
Bigger number.
larger
Larger number.
x value. You see how this takes us all the way back to module 4 when you were learning slope? Larger y value was y, larger x value is going to be x. All this stuff ties in together. You know how to do it one way? Just remember, okay, what's going to be my x2? Larger x value. This is x2, this has to be your y2. If this is x1, this has to be your y1. That's really the only place you can make that mistake. That, or if you forget those negatives in the formula. That's the only real places you can make mistakes. Corey, help me with the next one, dude. We're only going to do one of these. I'll let you guys pick which one you want to do. Want to do the first one? First one, second one?
First one.
More people say the first one.
First.
If I do the first one here, usually I do the second one with another class. I go back and forth. We'll do the first one. Okay, so looking at this, which one of these, which one of these is going to be my x2, dude? 9. So this is my x2. Right next to it is going to be the y2. Perfect. This is going to be my x1, and this is going to be my y1. Let's substitute it in. So d is going to equal the root of, what's my x2, class? 9. So 9, immediately write the minus sign. It's not a negative, so we don't have to do parentheses, so we'll do 9 minus 3 squared plus, what is my y2? 5 minus, what's the y1? 1 parentheses squared. Notice that here in the formula, the square raising to the second power is on the outside of the parentheses. Don't forget to do that. If you were to make a mistake and put it on the inside, now you have 9 minus 3 squared, which becomes 9 minus 9, which becomes 1. Totally wrong. Make sure you keep it on the outside of the parentheses. Let's go ahead and let's do the subtraction here. What's 9 minus 3? 6. So we end up with 6 squared plus, what is 5 minus 1? 4 squared, okay. That's going to give me, what is 6 squared?
36.
36 plus, what is 4 squared?
14. 16.
16. That gives me d is equal to the square root of 52. What is that to the nearest 10?
7.2.
7.2. So this is between 3.1 and 9.5 is 7.2. Did you guys want to do the last one?
Yeah.
Sure.
Yeah,
If
sure.
I have somebody saying yes, then we'll do yes. That means people want practice. I'm totally fine with that. We always put the extra example just in case. All right, so Madison, do me a favor. Looking up here, what is your x2 going to be? 4. So this is my x2, which means that this has to be my y2. When you're doing that index card, I highly recommend you put that formula on it. Don't forget, because you're not going to remember all that. That means this is what, Madison? That's the x1, and this is going to be your y1. Oh, I love it when zeros are in there. It makes the job so much easier. All right. D is equal to the root of, what are you writing, Madison?
4.
4. Immediately write the subtraction sign, and then parentheses, negative 1, parentheses, parentheses, squared, plus. What are you writing for the y's? That's a 2 there, by the way, guys. We did the plus, okay.
9.
9, okay, parentheses 9, minus 0, squared, okay, good. D equals, these two negatives become a positive, and you end up with the square root of 5 squared plus 9 minus 0 is 9, so 9 squared. Let's do the squaring. What's 5 squared? 25. What's 9 squared?
81.
81. We combine those together, we get
106.
106. And what's the root of 106? 10.3 is the distance between those two sets of coordinates. Any questions on this? Because that'll finish up 12, and then we'll go from there. Questions?